Are we live? Okay, we are live. So, okay, so what we're gonna do now? Okay, hello world. This is Andre. Let's try something new today. I'm going to do live video. Hey, by the way, how's your weekend, guys? Hope you enjoy and ready for Monday. Oke, jadi karena lagi nggak bisa tidur, and mostly my mind active at night, so let's do something. I don't know, live video, live coding maybe. This is going to be unscripted, so expect a long video. Ya sometimes kalau terlalu banyak rencana biasanya cuma wacana ya. Spontan kayaknya biasanya lebih seru. And I'm going to explore something tonight. I'm going to share my exploration, my learning. Sometimes I found a lot during learning yang kadang-kadang ya hilang begitu aja gitu kalau nggak di share. So this is my way to document my learning and also share my way of thinking, how I solve problem. Maybe do some light coding. I don't know. Not not trying to solve. Well, maybe a bit, but yeah, just to show how to get started. Sometimes it's easy to see people doing things just like that, but there's a learning process behind it. So I hope I can show you something. Okay. All right. So topik pertama malam ini adalah I got oh by the way, ini software yang gue pakai untuk live streaming, ya, OBS. Okay. First thing first, the one that I want to show you is I just got this stops, ESP-EYE, right? So pertama, let's unbox this thing. So we got this directly from Espressif. Espressif is the company that's developed ESP32 microcontroller and ESP8266. So they come up with latest development board. It's kind of mysterious lately, but they just finally released it to the public. And of course you can buy it, but yeah, it's not that easy to find apparently. You can't purchase it right now in Mouser, for example, but yeah, they say that the stock is not there yet. So okay, so it happens that my company is partner of Espressif in Indonesia, so we have the honor to get this, of course, for free. So it just ya baru datang kemarin. Let's see what's inside it. Okay, again, ESP-EYE. Ini schematicnya, ESP-32 as the microcontroller. It has camera, microphone, LED and button, and the interesting thing is that it has beside flash storage, it has PS RAM, pseudo static RAM, I believe, PS RAM, 8 megabyte. It's 8 megabyte of RAM. It's interesting. Okay, let's see what's inside. Alright, this is the board. ESP-EYE version 1.1, 2.1. Okay. It's got two buttons, boot and reset over here. And of course it has camera. Nanti kita lihat apa speknya. Microphone. It's a microphone. And over here is the ESP-32. One of these is PS RAM and flash. And this one is a USB to TTL. Antenna, 3D antenna, or Wi-Fi and Bluetooth. And you can use, I believe this one is a UFL. This one is a UFL connector, so you can solder the UFL connector to choose between antenna. You can use external Wi-Fi antenna or onboard antenna. Ini sebenarnya cukup penting karena let's say kita simpan board ini di dalam casing metal, you can't really use onboard antenna because radio cannot pass through the metallic enclosure, right? So you can use external antenna, right? So what else inside the box? What's inside the box is a micro USB cable and a quick start guide. Right, thank you Espressif for sending me this. Okay, let's see what we can do with it. Oops. So let's see. ESP-EYE. Okay. I think you can find the detail. I can find the details about ESP-EYE. here, um, okay, as I said, you can purchase it on Mouser, but uh, I don't think it's available. Oops, wow. I don't know. Uh, okay. Yeah, as you can see, it's restricted availability, so you cannot purchase it. Right. Okay. So what is it? So uh, as you can see, this is the Espressif's effort uh, to enter the AI and IoT solution. So you can think this board as a edge intelligence. So edge intelligence for um, yeah. So this is uh, upaya ekspresif untuk mewujudkan edge intelligence where the AI or machine learning bisa running the board or on the edge instead of on the cloud. Right? So edge intelligence is one of the trend currently in IoT and AI. So I think Espressif nggak mau ketinggalan di area ini, karena kalau kita lihat vendor yang lain, platform yang lain misalnya ST Micro, they already begin to explore on AI as well. This one. So you can use a ST Micro STM32 to do a AI on the edge. Okay. So in a way that you can for example do a object detection or speech recognition directly on the edge, directly on things, directly on microcontroller. So you don't have to send the data over the cloud, over the internet to the cloud, and do the inference or you know machine learning inference on the cloud. So that way, the system response is very fast, and you don't have to send anything to the cloud or for the internet. So of course, it will be very low latency, and there's also a privacy issue that yeah, basically you don't send anything to the cloud. I think that's one of the benefit of edge intelligence. So I think ESP-EYE is the expressive effort just about to do that. All right. Okay, so let's see. Okay, ESP-Fu. Okay. So this is how you can get started with this board. Right. Yeah, of course you can code the firmware using ESP-IDF, ESP32 intern IoT development framework IDF. Okay. Yeah, as you can see here, you can do face recognition, face detection directly using this board. Sorry, I forgot to switch. I forgot to switch. Okay. Okay. Let's do it again. Shit. Okay. So what I have just done is that I click getting started guide. Okay, here you can see the details about the ESP-EYE, what's peripherals it's on the board, how you can do software development, firmware development for ESP-EYE, of course using ESP IDF, Espressif IoT development framework IDF, and the available source code. You can use it for speech recognition, I believe. No, it's like a voice awake. Jadi kita bisa bangunin microcontroller ini dengan voice. It's more like Hey Siri or Hey Google or Hi Alexa, something like that. So as you can see that when it's woken up, ketika dia bangun, well, you can do anything. In this example, it's trying to connect to the network. Okay, so voice backup, and then you can do face detection. Hanya dengan board segede ini, you can do face detection and face recognition. Okay, so of course you know the difference between detection and recognition, right? So detection is basically detect whether there's a human, there's a ada orang di sebuah video stream or on image. Recognition is recognize who is on the image, on the video stream, right? And of course you can do enrollment. So basically you add the face that you want to recognize. That's what we call it, enrollment. Yeah, it's good. Okay. So what we going to do now? What we're going to do now? Okay. Before moving forward, let's see the schematics of the development board, so we can explore what inside, how it's connected. For example, how is the camera connected to the ESP32? Okay, let's see. We can see schematics. Okay. CP 2102 is the USB to TTL, ESP, power supply, voltage regulator, LED, button, microphone. So microphone is connected to IO26, IO32, 33. Okay, this is the ESP32, and this is the camera connector. So this is the connection between the camera and the ESP32. Okay, so IO 18, 23, 5, 27, 4, 25. Okay, this is interesting. IO 13 and IO 14. This is interesting because this pin usually used for JTAG connection. Okay. 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 Again, guys. So this is the ESP-EYE. It's Espressif latest development board for AIoT, AI plus IoT. Disingkat AIoT. So that's new term that I also found last year's during my trip in Taiwan. So it's kind of hard right now in China and Taiwan, AIoT. So make sure you guys also prepare for that. So what can we do with this? I'm thinking about to access the camera, to access the stream from camera, and using using Azure custom vision. So using so taking the image using this camera and then using Azure custom vision to recognize, to classify, or to detect object inside the image or video stream. I think we can do that. I think we can do that. So okay, but how we can access the ESP-EYE? Of course, we don't want to start from scratch. I think we can use this ESP-HU for getting started. So ESP-HU is a face detection recognition platform. It's developed by, of course, it's developed using ESP-IDF. Right, as you can see here, ESP-IDF. You can see the example here. Okay. This is how you can access the camera. Right. Okay. All right. Let's do it. Let's change the color. Okay. Okay, let's clone it. Let's go. I forget how to clone. Yeah. Oh. Oh yeah, yeah. I think I already have. I think I already have it. For self. I think I already have it. I've, oh yeah. All right. So I think I already have it. Okay. Let's pull the latest. Okay, already up to that. Great. Okay. So. Let me open it. Okay, let me open it with. Okay. Okay. Is it still working? Is it still working? Okay. Okay, so let's see the example. Okay, so this one is camera web server. I believe this one is this code is accessing the camera and then stream the video stream using web server, HTTP server, which you can use browser to view the stream. And okay, I'm more interested on the camera. So how we can access the camera, right? Okay. Is it live streaming still working? Okay. So to get started, okay, so to code this one, I'm going to use, of course, ESP-IDF, but I'm not going to use VS Code. I'm going to use Eclipse. Okay. So to so to wait, just why don't we use a why why no why can I use this one? So to start a new project with Eclipse, I'm going to copy the template. This is my own template because I already setting fat and you know includes kind of things, so I don't have to redo everything all over again. So let's see, we can call it ESP custom vision. Okay, now we can import that project into Eclipse. Okay. Okay. So you can find I broke it out. Gimana sih? Lupa cara ngezoom. Okay, forget it. I hope you guys can see it. So this is the new project, right? So I already have the main.cpp. This is the entry point for the application. We have component config makefile. Can change this to something like that. Okay. And so okay, for my default project for ESP-IDF, I always link to the Arduino components so that I can use Arduino library or Arduino frameworks on my ESP-IDF project, right? Well, because why? Because Arduino is easier. It's easy to understand, easy to use. and there are already a lot of libraries to work with sensors or peripherals, so I don't have to rewrite everything. Okay, so if you see, and I always link to the Arduino repository that I download on my local machine, so I don't have to copy everything for each project that I made, right? Okay, so to work with the camera, there is a something called ESP camera, which I believe this is the component. Okay, because if you see the because if you see the project, there's a link to ESP32 camera that happens to be made by Espressif as well. Okay, so let's clone that. Why don't we just copy? Why don't we just copy it to the? So we copy ESP32 camera, right? Okay, right. Okay, we got this. Okay, to use it, I think I can just copy paste, right? So just copy paste. All right. So first thing first, we define this camera model ESP-EYE. This thing is okay, and this one go to the ESP camera H. Find that. Okay, let's see. Camera unit. Camera unit. Okay. Okay. Okay, we can just copy paste this one, right? Okay, this is important because tadi kan gue bilang IO13, IO14 dipakai oleh kamera IO13, I14 is designed for GTAC, so we can, jadi kita nggak bisa langsung pakai begitu aja. So I think I have to copy this as well. I hope you guys can see it. Okay. Okay. So to access the camera, let's see what it has. Okay. Config. Right. It first. It's have to pass the pointer apparently. ESP-EYE tag camera init field. Just return it. Just return the result. ESP-LT and we can ESP-LT camera init. Right. Okay, since I want to use Arduino framework, so as you can see here, I don't set the Arduino framework as auto start, so meaning I have to manually start or init the Arduino framework to be used within ESP-IDE. So init Arduino, right? Okay. Okay. I think we can use it. Right. Okay. While we here, let's make sure the serial port is connected to, is selected to USB TTL of this board. Okay, let's plug it in. Oke, kita colok ya. So to make sure, step 2. Oke, kalau kita lihat di sini belum ada, belum terdeteksi USB TTL dari board ini. Let's plug it in. Okay, as you can see, there's a new what do we call it, serial port. So make sure it is exactly it. Okay. Okay, I think so. Okay, let's build this. Make G8. G8 meaning there's a there are 8 parallel processes to do the compiling. Okay. So I'm going to smoke. Don't try this at home. Okay. Tolong jangan ditiru. This is bad habit. Please. Yang di bawah umur, tolong jangan ditiru. Okay. Anybody still watching it? Okay. Somebody is still watching it. Okay. So, as we can see that the make is successful. Okay, I think we can just flash this to the ESP-EYE development board. Okay, let's just all right. Camera init success. Yay! That's easy. That's easy though. Okay, now what? Hmm. Now what? Okay. Sekarang kita coba akses frame buffer or video stream coming from the camera and display the image somewhere. Okay. How we can do that? Yeah, I think we can. Kita bisa tiru kamera web server ini. So this one is using HTTP server. This one is component built in inside the ESP-EYE app. I never used it before. So yeah, definitely gonna take some time to explore about this. But I do have experience using something called ESP-async web server. Oh, yeah. So I have the experience to use ESP-async web server. Right? So let's use it. So let's use this ESP-async web server to serve the request from the browser to take the photos from camera and then view the result on the browser. Okay, let's do that. Why is okay? Okay, let's clone this one first. Is it any? Okay. Okay. So we have to also clone this one. I forgot to start recording though. Let's do some recording for this stream. Never mind. Let's do some recording. Movies. Okay. Okay, so we have cloned the Async TCP and ESP Async web server. So start web server. Include ESP Async. Web server. This is this is an example. Forget how to. Of course, we cannot remember all the thing, right? This example, this. Async web server. Okay. And then okay. Let's try this one first. So then we have to, I think we have to, okay, yeah. We have to explicitly begin the server. Right? And of course, we have to start the Wi-Fi. Put the Wi-Fi here. Right? What is this? Ah, okay. Okay, let's define some SSID. I'm using my okay. Of course, you can see my SSID password, but I can just change it. Right. Let me check whether it's and this iPhone X. Okay. Okay. All right. Okay. So the idea here is that after the camera has been successfully in it, then we start the web server. So that the web server can be accessed from my computer, from my laptop. The this board has to be connected to this same access point that my laptop connected to, which in this case my iPhone. And then after that we begin the web server. Okay, let's try it. Flash it. Boom.